Hi, my name is Taylor Harris. I am an environment artist, and I am here to continue the breakdown of this scene I made. In the previous video, I talked mainly about my process and the lessons I learned and the challenges I faced. But in this video, we're going to talk more about the technical components to how I assembled different parts of the scene. So we're going to go over a lot of Unreal materials, how to add a gradient to the world even if it wasn't in your original texture file, how I made the trees, how to make a kind of fake window interior with just a material, and then real quickly I'm going to go over the siding on the house there, and particularly how to add variation to it so it looks a little more interesting. So before we dive into all of that, I just want to give credit to the original artist of this painting, who is Mateusz Urbanovic, and I encourage you to check out his YouTube channel. He does a lot of painting and live streams. So with that, let's get started. Alright, so the question I get the most about this piece is how I did the trees, but we're actually going to start by talking about the staircase here, because there's some requisite knowledge that gets used in the trees, and that's basically that I added kind of a subtle gradient from the base of these stairs up to the top, yet this material on the bottom is being reused at the top and they look different. So how did that happen? If I take a screenshot here and pop over into Photoshop, you'll see kind of an example of what I'm talking about. So there, if you look at it side by side, you can see how much darker it actually is at the bottom. And let's look over in Unreal a little more closely. Pop out of my camera. Alright, so each one of these steps is just one of three different kind of stone pieces that I'm just duplicating, and there's a single material applied to all of them. And you have to forgive how bad these look up close. They're really meant to see more from this distance. So I like how it looks here, but never intended to show anyone this close, so please forgive that. So basically, the way I am achieving that gradient is by using a node in Unreal Materials called Absolute World Position that looks at the height in the world and uses that information to drive a material. So let me show you. Alright, so here's the actual stone material, and this is that node I was talking about, Absolute World Position. Before I kind of talk about what's happening here, I want to kind of explain what this does to people who might be new to Unreal and not used to kind of working with this sort of system. So let's close that. I'm going to make a little dummy sphere to demonstrate on here. Let's pull him out somewhere where we can see him and make him bigger. Alright, so now we're going to make a new material. We'll call this World Position. Open that guy up. And let's see. There we go. So it was called Absolute World Position, but if you start to type that, you'll see that it doesn't find anything called absolute. And that's just a quirk of Unreal. If we call it World Position, you see it right here, and then it gives it that name. So just keep that in mind. And to demonstrate, this is the actual node we'll use, but to demonstrate it, I'm going to kind of use a sister node that's very similar called Pixel Normal WS. The WS stands for World Space. So each of these nodes output three channels of information, basically red, green, blue, but those correlate to X, Y, and Z axes in the world. So if I plug this into base color and hit save and then drag it onto my sphere here, we get this kind of psychedelic beach ball material. And I remember when I was first learning Unreal, I was very perplexed at how would I ever use this information to do something I actually want, other than making beach balls? But once you understand what it's doing, it's not that complex. So now what I'm going to do is make a copy of it as a control. Duplicate our material here. And I'm going to put this one on the right. So the right will be our control, and then we're going to change some things about the one on the left. So I said it was 3 channels of information, and we can filter to any one of them by dragging off of that node and type channel. We get this channel mask parameter. So I'll click one of those and plug this into color. And you can see right now it says it's set to red, and you can also change that down here. But if I hit save, you'll see suddenly we no longer have a beach ball, but this black and white kind of half and half thing going on. And if we look at our control sphere, you'll notice that we're in the red channel, and all the red information is on the left side here, and on the left side of our sphere is where the white information is. So if we go back around to the front, and I'm going to change this red channel to green, now we're filtering from front to back. Similarly, that's where all the green information is. So you can probably guess what's going to happen when we change to blue. Now it's filtering from top to bottom, and that's exactly what we want for our stairs here. So this pixel normal world space is just relative to the pixels on this individual object, but we don't want it to be relative to the object. We want it to be relative to the world, and that's where our absolute world position comes in. So if I swap this node out, get rid of this guy, we don't need our control sphere anymore. If I hit save, you'll see that everything turns white, and that's why I started with the other one as an example, because it's easier to visualize what it's doing. But if I jump over into Photoshop and show you kind of a mock-up of what's happening right now. So this is basically our world. We got our grass down here at the bottom, sky up at the top. We have basically just made a gradient that stretches from the top of the world to the bottom of the world, and this is our sphere. So wherever our object with this material exists in the world, if we move it around, it will adopt the color of that gradient at that height. Because we set it to the blue channel, which is up and down. You could do the same for left and right or forward and back. But what we want to do is basically we want to control where that gradient is. So we want to, let's see, I don't want that layer mask there. We want to push and pull the black and white points so that it gives us a tighter gradient right on the object that we're working with, sort of like that. So how do we do that in Unreal? Well, once you get used to working in Unreal materials, you start to associate white with the number 1 and black with the number 0. And from there, you're just doing some math to kind of push those boundaries around. So what I'm going to do is I'm going to add a multiply node by holding the M key. We're going to plug that in like so. And then we need a value to multiply this against, because this is basically a 1. It looks like almost pure white, and we want to reduce that. So we're going to need to multiply it to a value smaller than 1. So I'm going to create a scalar value by holding S. We're going to call this multiply value. I'm going to plug that in there. And now currently it's defaults to a value of 0, and multiplying any value times 0 will give you 0. So when I hit save, this is going to turn black. And we don't want that. We want to get some gray tones or maybe a little bit of a gradient. So I know from past experience that we're going to use very, very small values. Like our world is very tall, but this sphere is only about 3 meters tall. So we need to really clamp that in. So I want about 5 zeros here and a 1. And our maximum value is going to be 0.001. You might have to alter these values in your own scene depending on how big it is. Let me hit save. And then as I start to drag this, you can see that gradient is starting to shift. We're pushing it up and down. And this is the basic concept for what I did on the staircase there. Is I just applied the material to all the stairs and then pushed the value around until it kind of hit the sweet spot of what I wanted. So with that, I don't think we need this sphere anymore, and we can jump into the actual material. All right, so let's go in and look at these stairs. Like I said, each one is just a duplicate of one of 3 different pieces of stone, and then they all have the same material applied. So if we bring that guy back up, let's kind of enlarge the view here so you can see the whole thing. All right, so the only interesting things are happening in the color channel. Otherwise, I just have a spec value 0.5, roughness 0.5, got a normal map, ambient occlusion. It's also plugged into the metalness, but that's just black. Nothing interesting going on here, so I'm just going to move it out of the way. Everything we care about right now is just in this color area. So let's simplify this down. I'll explain this node in a minute, but right now I'm just going to set it to 1. And we're going to look over here. So here's our absolute world position. This is looking at the height positions in the world and driving our gradient. It's also filtered through the blue channel. This is the number that I multiplied it by. But to make the gradient a little bit more obvious, let's make some brighter colors to demonstrate this. I'm going to move these guys out of the way. I'm going to make a 3 constant vector by holding 3 and clicking. Make another one. And let's see, let's make this one a bright red. Let's make this one a strong green. Let's plug these into our gradient and save. And now you can see the gradient a lot more clearly. And if I go to that multiplier value and I push and pull that around, I just got to remember that number 857. You can see I can push it up or down depending on where I want it. That was 0857. There we go. All right, so now that everything in this box here is controlling the gradient, the colors we're using, and the boundaries of it, let's move forward. So this is the only actual bitmap in the color part of the texture, and all it is if I enlarge it, it's just really loose scribbles over the edges of the step. And it's in black and white, so it's acting as a mask. And basically what's happening right now is these colors are being output and fed through here into this lerp. Then this is masking it and saying, okay, anywhere it's white, multiply it by this value to highlight the edges. But right now, that multiplier is at 1, so it's showing the same thing on both the black and white parts of this mask. If I change this value and raise this from 1 to something higher, you'll see that the edges start to get brighter. And similarly, if I lower those values below 1, I can make them darker. So that was at, was it 0.0, no, 179? Oh, no. Gotta find it. Oh, 1.79. All right, so that's the value I had by default. And you can see it's just taking the same tone from the base texture and just making it a little brighter. And that changes based on the gradient. So at the bottom, it's taking this red color and making it an orange color. And up here, it's taking a green color and making it a brighter green. So I think we can go back and get rid of this red and green and plug in the actual materials. And there we go. That is the basic setup for the color there. It's kind of a neat trick because it allows you to have this gradient, but I didn't have to do anything like make a giant texture that had the gradient already built in. I can just reuse the same asset over and over and still get that gradient look that's very important for stylized art. So that concept will come into play in a moment when we talk about the trees. All right, so let's talk about these trees. One thing I find really fascinating about CG trees is that there's so many different ways you can do them. There's no right or wrong way, just every artist has a different method. And I need to stress that the way I came up with is it by no means the best way that you should always do. It just happened to match the style I was going for when looking at the original concept. It's very polygon heavy and wouldn't be appropriate for games, but let's take a look at how I made them. So the first thing I did was to study the original concept. So up here on the top is the original painting, and I traced over it in Photoshop to kind of get an understanding of the forms I was working with. I'd then hide that background layer and just look at the shapes, and I'd get these kind of chicken tender looking shapes. And that's when I decided that this tree on the left is kind of the hero tree that would take the most work to get right. And if I could get that, then it looked like the rest of these trees were more simplistic. On the left here is where we have most of the trunk and branches and the actual structure of the tree, where this is more just kind of floating clouds with an occasional kind of indication of tree branches, but they're not really clearly defined. And then I also was noticing how there's never really individual leaves clearly defined. It's more like a green cloud, and we're just kind of seeing these patterns of highlights, midtones, and then shadows, but not individual leaves so much. So that, in conjunction with the fact that I wanted it to keep it looking a little bit painted if I could, those were my kind of guiding principles. So let's look at my Unreal scene here. So if I hit G to reveal the game elements, I've got my camera here, and then I set up a plane that has the original painting mapped onto it. I constrain this to the camera so that if I pop into my camera view, I get this, I made this kind of tiling opacity map so that I could position things to match the composition of the piece. So I matched kind of the shapes and forms of the trees by selecting one. I can't select it while I'm in view. Hang on. Actually, I would typically use a second viewport like this. So I might have my camera here set to be the one that has that view. And then over here I can hide it. But if I select an element like this up here, you can see how, let me make this a little bigger. It still maintains that yellow outline even when the image is mapped on top of it. So I could kind of move this around and place it to match where I wanted it. So that's kind of how I staged the scene. But let's talk about how I made that geometry. Alright, so I'm over here in 3D Studio Max now. These are the basic branch and trunk parts I made. This is the main trunk of that hero tree. The rest of the branches I knew I could just make really simplistic shapes, and I could rotate them around or scale them to get the other branches I needed. These basically are just, I started with a cylinder and kind of bent them into shape, and I think I probably put a turbo smooth on to get smoother transitions. I then ported them over to ZBrush and did a very kind of crude sculpt just to give a little bit of detail. I knew these were going to be the farthest object from the camera, and at that time I wasn't sure if I was going to be using depth of field or not, so I knew that no one was ever going to see these up close, and I just did that so that I could use substance to kind of add some noise and variation in the colors. So the trunk's really simple, didn't really spend much time on those. It's mainly the foliage that I spent a lot of time on. So ultimately what I did was I used a particle system inside 3D Studio Max, and each particle was an individual leaf. So if I look at a little image I made here, this was the basic concept. I have a single triangle with an alpha mask of a leaf on it. So every single leaf is an individual triangle, and that's why the poly count is so high. I tested different opacity map shapes. Ultimately, I went with just a circle because that gave me kind of the smooth, continuous look I wanted, that kind of cloud-like look. When I used this multi-point kind of cluster of leaves, it looked very kind of noisy, and there were a lot of angular, sharp shapes that I didn't think matched the concept. But the basic principle is I'd make a volume that acts as the distribution object, and then I would tell the particle system in Max, okay, make a bunch of particles inside this shape, and each one of those will be a leaf. So contrary to that image we were just looking at where I have this kind of tongue shape, I tried a lot of different shapes, and I was not able to kind of construct the forms I wanted. So ultimately, I found an artist whose work really helped me out a lot. Oops, this guy, Jonathan van Immerziel. Of all the trees I found, I thought the ones he made here were the closest to what I wanted to mimic. If you look at these ones that are kind of more distant, that does kind of have an almost painted look where it just looks like kind of brush strokes of different shades of green, and that's what I wanted. So I was very fortunate that he linked here to a Trello page of his, and he broke down a lot of his trial and error and different processes. Like here he's talking about trying static lighting versus dynamic lighting. So I got to learn a lot from his trials. And if you're watching this, Jonathan, thank you very much. I like your trees a lot. So the other thing I noticed from his trees is that he was using these spherical forms. His is also very stylized. So contrary to that tongue shape I was using, I decided I would use his approach, and that's when I decided to make these spherical forms. I've got 6 different sizes ranging from, this is a 50 centimeter diameter sphere, and this one is 1500. So I generated leaves on each of these. I kind of enlarged the scale of the individual leaves as the sphere got larger, because that way I could conserve a little bit more polygons. Like if these leaves were as small as they were in this smallest sphere here, like it would take many, many more polygons to fill that space. So I kind of scaled them up as the sphere got bigger. So once I had that down, the next part is a technique called custom vertex normals. So let's take a look at that. All right, so if you Google the phrase custom vertex normals, you'll find this article from Polycount that says foliage polycount. And my understanding is that this is a pretty old page that's stood the test of time, but what we want to look at is this image here. So you've probably seen or made trees of your own before that had this kind of look where you can see the different intersecting planes of the geometry, and it looks very artificial. So by using this technique called custom vertex normals, you can kind of trick the geometry into blending together better. So how do we do that? And this process is going to vary depending on what your 3D modeling software is. I use 3D Studio Max, and my understanding is that Max doesn't have any built-in tools to handle that, so I had to download a custom script to do it. And because I don't know how long that script will be supported, I'm not going to kind of go through the details of how to use it, but I would just recommend doing a Google search for the term custom vertex normals, trees, and then the name of your software. And you'll find articles of people saying how to do it because it's a pretty common practice. But basically the idea is, let me find my image here, that you have your foliage object in the center here, and then you make some sort of geometry containing it. And then you use either the tools in your software or a plugin to say, okay, take all the different normals from all these different polygons and make them mimic this shape that I've enclosed them in. So it'll look at, say, the polygons over here, and it'll say, what's the closest part of the geometry? Like, oh, it's this side of the dome, and that normal is pointing outward. So even if the actual normal on the polygon is, pointing off to the left, it will use the normal that's pointing off to the right to mimic this dome shape. And then, this is it before that process, and then after you run that process, it'll look more like this. And this screenshot is just from 3D Studio Max, so it's not a proper lighting, but you can still see the shift. It's disguising those intersecting planes a lot better. So when I look through various tutorials and examples of other people doing this process, every single one I found, people would put a dome around the shape, like there's no underside. And I was curious why it was always a dome and not a sphere. So I decided to do some tests to see the difference between the two. Hop back over into Max. So these examples I have here, again, inside the Max viewport, we're not getting proper lighting, so take this with a grain of salt here. But these ones on the left, I am using a dome shape to change the normals, and on the right, I'm using a sphere shape. So I generated all these, then I brought them into Unreal to kind of compare how they would look. Here we go. And I'm testing actually a lot more things than just that, but these ones that I've circled here, the ones on the left are using a dome shape around them. Let me zoom in on this. So these ones on the left are using a dome, and the ones on the right are using a sphere. And you can see the primary difference is that the sphere one, you get more of a shadow on the underside because there was actually geometry on the bottom pointing downward with its normals, where the dome didn't have that. So when I compare to my original source image, I thought that the pattern I was seeing here in these forms was like a highlight on the top of each little cluster of foliage, then kind of midtones, and then a shadow. Then it goes back to highlight, midtone, shadow, highlight, midtone, shadow. And because I was seeing that pattern, I decided I would use the normals of spheres instead of domes. Alright, so this next bit is something that I'm actually pretty excited about. This was something I had wanted to experiment with for about a year, and I finally got around to doing it, even though this scene doesn't fully utilize it, and that's making a false interior on the inside of a window. So if we move around, you can see that I just kind of have blurry shadows in here, kind of showing where the ceiling meets the wall. But if we were to kind of orbit around, you can kind of see that it looks like there's a false interior. If I go up, those move, and downward, it'd be more obvious if that was a realistic interior. So let me jump into another scene and show you what I'm talking about. So here I've taken a Cornell Box Image. If you're not familiar with that, it's just kind of a famous series of images where people compare photographs of a scene with a kind of a CG duplicate to see how accurate their render engine is. But my reason for using it was just I needed an image that has kind of a back wall, a wall on either side, and a ceiling and floor. And I thought this was a good example image to start with. And then I took that image into Photoshop here, and I kind of distorted it. So this is the original, and then for my purposes, like I threw it in the Unreal, and the dimensions of the room didn't seem quite right, so I distorted it like this. I don't really care about the spheres because I'm only testing out the walls and ceiling. But for your purposes, depending on the size of the room you're trying to fake, you might need to do something like this, where you squeeze it in a different direction. I just recommend kind of prototyping it out with an image like this before you do any kind of detailed interior, because you might put it into the engine and see that the proportions don't look right. So this helps you figure that out. So I took this image that I altered, went into Unreal, and if I map it directly on that surface, it just kind of looks like a picture in a picture frame right now. Like, that's what we would expect. So first I'll show you the end result, and then we'll go through the material network of how you make it. So bump offset is our primary feature, and the bump offset feature, what it does is it kind of adds this parallaxing effect to where it'll appear to zoom in, but then if we move from side to side, it kind of parallaxes. So I use this value here, and that's the bulk of what we're going to do, but we can take it further by making it look like there's a reflective glass surface in the front. So if I start to turn on some of these other features, I have some emissive properties coming in, so it looks like there's light. I'm going to tint the glass so not all of the light is escaping. Some of it is being blocked by the window. Add some specularity and make it glossy. And then as we move around, now if you had a full scene with other like buildings or cars in front of this building, you'd see that reflecting in, and I think that's a pretty convincing interior. And personally, I'm just so fascinated with how easily you can get this kind of result without having to model anything. So you get a lot of bang for your buck, as long as this isn't a focal point where, like say in a game, a player is going to come in and look in the window. It starts to break down as you get close. But if this is a background element that you just want to get done efficiently, this is a really good way to do it. So let's take a look inside of that material. All right, so this is the material instance where I was just changing some values, but if we go into the master material here, there are a lot of nodes here, and I think to keep this quick, rather than break down every single thing that's happening, I'm just going to kind of go through it quickly, and you can pause or rewind as you need to if you want to duplicate this effect. So a lot of the bump offset features are happening here. This is what's faking the depth, and this stuff here is more for creating the kind of glossy glass surface in front of it. So I will zoom in here and give you a shot to see this part all mapped out. So this is a scalar parameter. All of the numeric values I've made parameters so that I could alter them in this material instance. So that's a scalar parameter. I have it set to 0.35. This is a texture coordinate. Those two are being multiplied together. Then I've got a subtract node here. The A value is hard-coded to 1, and then I've got my scale feeding into it. This, honestly, I did this so long ago, I can't really tell you the reason for why I did some of this math. I think it had to do with as that bump offset value is changed. Let me demonstrate. So as this zooms in and out, it kind of would become off-centered, such that maybe we would be really zoomed into one corner of the room. And I think that math kind of helps keep it more or less centered so it looks the way I want. So I think that's what the bulk of the math is doing. So back to here, we have the subtract node going into a divide node. Its B value is hard-coded to 2. Subtract is wired into A. This is wired into a panner coordinate, which usually, is used to have a texture animate in one direction. But in this case, I've set both the time and speed to 0. I'm not really using it to animate anything. This divide node is piped into the coordinate value. This feeds into the add node, into the B slot. Previous multiply goes into the A slot. Then I have a bump offset node. That's our workhorse. That add node gets pumped into the coordinate, 0 into the height. And then this is our color map, that Cornell Box Image. and this bump offset gets plugged into the UV slot for that. So that's how the bump offset works. Over here, if we look at the rest of the material, I have a multiplier here that's a scalar value plugged into a multiply, and this is the emissive strength of that image. So I multiply those together and plug that into emissive, whereas otherwise this color map goes up here into a multiply node. There is a window tint scalar value here, and right now that's set to 0, but in my material instance that's what controls how dark the glass is, like how much of that emissive light gets through. So that gets plugged into this add node. I've got kind of a haze around the edges of the window to simulate kind of some dirt. So if we look at that here, you can kind of see how we can pull the haze around that edge up and down. So that's what this portion is controlling. This is the mask that shows where the haze is. This is the color of the haze. And then this is the multiplier that determines how strong the haze appears. So if it's set to 0, then none of that haze shows up. So multiply node, mask, scalar value. That's a constant 3 vector. It's just a color. You could use some sort of noise map if you wanted to. Plug that into multiply. These get added to the bump offset image that we piped in up here, and that all plugs into color. The specular has a scalar value. The roughness has a scalar value. For glossier glass, you set the roughness to 0 and specular up to 1. So that is how that works. So this is a technique that you could use not just in stylized art, it could be realistic, just anytime you want to kind of cheaply simulate an interior of a window. Alright, so in the previous video I mentioned that I would talk about how I added the variation and randomness that this wood siding has. If you didn't see that video, I talked about how I had this material on there. It was like the very first material I put in the scene, and it came from Megascan, so it was just these very perfectly straight wood slats, and I left it that way for months and I hated it. And it wasn't until I finally took the plunge and decided to go and add some geometry that I added some random elements to that it finally started to look like the concept, and I'm pretty happy with it how it came out. So I mentioned it in the previous video, so I'll just briefly show how I did that. It's not rocket science, so I'll go over it pretty quickly. So here it is in Unreal, and I think in that previous video I said it was just a texture, but there is actually some geometry there, so each beam does kind of have an edge that sticks out. But let's look at that in Max. So here is the... Sorry about that. Alexa thought I was asking about a movie. Okay, so here's the piece of geometry. And you see I've added these kind of cuts here and then moved the vertices such that there's a little bit of variation in the thickness and height. And part of what made me hesitant to do this was because in my mind, before I actually did it, I envisioned having to go in vertice by vertice and kind of pulling things around. But real quickly here, I want to show you like the method I used that was actually pretty efficient. So make our plane here. It is 800 centimeters by 400 tall. That doesn't look right. Other way around. 400, 800. All right. There we go. All right, if memory serves, I think there are 9 planks tall, maybe one more. Let's say it's like that. Okay, so now we've got the divisions for our planks here. I'm going to convert this to editable poly. Select these edges, do select ring, connect. Now I'm going to constrain this to edge so I can pull these edges down until they meet the one below. Then slightly pull it back up, turn off edge constraint, and if I go to a side view, I can pull out these edges about that much. And now we've got that zigzag shape. I'm going to turn off the smoothing. All right, so now we have the basic form of our wood siding. What I'm going to do now is select every other beam here. Then I'm going to convert selection to faces, detach to element. So now these are all the same object, but I can individually select a beam. Now here's where the randomization comes in. I didn't go in and make each of these cuts individually. I selected all of these, did a quick slice, kind of something like this. All right, now we have that cut going through. Now I'm going to select all my vertices and add a noise modifier. Noise, noise, noise. Now I don't want these edge vertices to go left or right because I have the dimensions I want. So we will be careful. I believe that is the x-axis. And I always have to play with these values until it looks good. So something in this neighborhood. I'm going to pull down some of these values. Kind of look at it from the side to see how far in and back it goes. Maybe something like that. Then I'm going to go back to edit poly. Now I'm going to select not the edge vertices, but just these ones in this kind of V shape I cut. I'm going to do another noise modifier because these ones I do want to move left and right, unlike the edges of the wall. Noise. All right, so now I can kind of play with that left and right noise. All right, so it doesn't look like anything special yet. Let me go back and make some of these values a little stronger, just to exaggerate. Okay, so let's say we have something like that. Now I'm going to convert this to poly, collapse all that down. Now I'm going to take each beam and just kind of randomly move it out of position because I want to reorder these so I don't have that clearly defined V cut going through. I'm going to keep the top and bottom beams in place so I remember where the top and bottom of the wall is. And then I'm just going to kind of randomly start slotting these back into place. All right, and you can see you're going to have some gaps like this, and that's fine because we can kind of scale these. We're going for randomness, so we don't have to keep them all perfectly the same scale they used to be. In fact, what I'm going to do is I'm going to put a plane behind this that's really brightly colored so I can see any gaps easily behind it. And let's see here. Maybe scale this guy up. And I did see that when I was repositioning these slats, there were two, these guys here just happened to still share that cut. So what I'm going to do is I'm going to scale this sideways, negative 100%. Put on my vertex snap. Where are my snaps? I use a different set of UI and hotkeys than I do at work, so sometimes I have to search to find things. Okay, snap that to the side. I'm going to flip the normals the other way since I scaled it. And now those cuts no longer line up, so it looks a little bit more random. All right, so now I just go through and fix the gaps. Make this guy a little taller. Oops. Do a quick auto smooth, see if I can kind of get rid of these triangulation lines. Let's see, does that work? Smooth a little too much, so I'm going to lower the tolerance to say 30. Auto smooth. That looks more like what I want. See another gap here. All right, so there is my kind of randomized wall. From here, I took all the exterior edges of these planks. Let me get rid of that pink guy. We don't need him anymore. And I pulled them back to kind of add some depth. From here, I brought it over into ZBrush, and I just really crudely dinged up all the edges, kind of lightly went over the flat faces. So then I could take it into Substance Painter and use the curvature map and ambient occlusion to kind of generate some of these shapes, because I didn't hand paint any of this. This all just came from the ZBrush sculpt. So I think with that, I will end it. Hopefully that was useful. Thank you very much for watching this series, and I really appreciate all your positive feedback. Thanks.